Hello and welcome to another episode of Spec Steppin, where we're stepping through the web API spec. And in today's episode, we're going to talk about the computer pressure API. Just a note before we dive in, this is still experimental in nature, so I would not recommend using any experimental technologies in production, but these are things you need to maybe keep an eye on as they get released and are no longer experimental. You might want to implement them. So the computer pressure, should say the compute pressure API, what does that do? Well, let's imagine you have an application that is a robust application that's using a lot of resources, like a video conferencing type application like a Zoom or, uh, Teams or, Slack or whatever your Google Hangout, whatever your web conferencing is. And that doesn't have to be just video conferencing, it could be any sort of robust thing. Well, some of those applications take a lot of resources to really do well. And you want to make sure that you have the best user experience possible. What the compute pressure API does is it allows you to look at things like the CPU, is currently what we're going to look at today, and say, okay, keep an eye on that CPU. Keep an eye on how much of that we're using. And if we're getting into issues with maybe someone has a little bit older computer or a little less high quality CPU, then they might run into some issues using your application. So keep an eye on that. And if we're getting into some critical areas where we might have a poor user experience, let's make some decisions in the code about how to do things. Maybe we'll lower the frame per second, the FPS rate on a video conferencing. Maybe we'll offload some of the functionality to a web worker, that sort of thing. There's a whole bunch of things we can choose to do that. So, in the documentation, they actually talk about video conferencing and give some concepts of usage and all that stuff, and talk about the different states. And they go, if I go all the way down here, they have browser compatibility here. Currently, it's only in Chrome and Edge and Opera. So it's not in Firefox or Safari yet, as you can see as of the recording of this video. So let me jump into the code here. First, the HTML is fairly straightforward, not too much in the HTML, just to make it look nice and so we can have an interface with which we can work. So I have some basic styles. Now, the styles are just straightforward styles where, and you'll be able to access this code and everything, where I just have some basic colors. I have some colors tied to the different states, have basic margin and padding, just normal styles, nothing really fancy there. And then the HTML is just, it's fairly, to be honest with you, a blah looking HTML. So I just have a link that I have to the API docs up here. And then I have a list of the environment to see if it's supported. Then I have some controls where we can choose to start observing or not stop observing the compute pressure. And then I have a status indicator of how long it's been computing and all that stuff. And then I can actually we have a way that we can put stress on a CPU. Now, in full disclosure, the computer on which I'm working is a pretty powerful computer. So putting stress on it via this API, I was not able to get it to stress out because I basically bought a higher end computer, so I didn't ever have to worry about this stuff. So actually testing this would be, I'd probably have to put it in an emulation environment to do that, which I'm not going to do today. And then I just have a place where I'm just logging information. Okay, so let's go and let's take a look at it. And then I'm going to come back to the code and show it to you here. So here we have, I always like to have my console open just in case. Um, so here we have just a basic setup like I just showed you in the HTML. I'm using HTTPS in my local host environment. It is available because I'm using Brave, which is a Chromium-based browser. I'm supporting the CPU, and right now the observation is stopped. So here, the only thing I have that's available right now is a CPU. And once I click Start Observing, it'll fill in the latest state and time. I can put stress on it. Again, I've not been able to stress it out because of the quality of my CPU. And then changelog, you'll start seeing this stuff fill in. So let me just click Start Observing. You can see it's nominal. It's about the middle of the afternoon here, and it's just logging every second the status of the current CPU. Now I can actually put a lot of stress on it here. And I started the stress worker. I have it running in a web worker and it's not doing any stress because of the quality of my CPU. And I can just click stop observing to stop it. So now I'm putting these controls start and stop, but if you're wanting to make use of this to make some changes to the end user's experience, you'd probably have it start up in init automatically, which I have a little bit of that in the code. So let's jump over to the code here. First thing I'm doing is I'm just grabbing all the pieces of the DOM. That's all I'm doing right up here. And then I have a little utility function called log. That's just logging to the bottom of the page what's going on. So I'm just grabbing that and it just creates a div and a paragraph and span tag and all that stuff just to fill that in down at the bottom. Nothing super fancy. And then I have the timestamp I'm just formatting it so I can get a nice uh, looking clock and stuff when it's formatting what the time is rather than that, whole on Unix based timestamp. And then this constant is updating the UI based on the state. So it passes the state and the time, whether it's nominal, fair, serious, or critical. Those are the four states that the API currently recognizes. And so if the state is one of these, it's nominal, or I can add the state save time. So I'm basically deconstructing whether it's safe or not. And then otherwise, I'm saying there's no time, no data. So I'm just logging whether it's nominal or not. Then I have this is my stress worker, my optional stress worker here. So I just basically created a web worker. And in this web worker, it's just going through and creating loops to put some stress on the CPU. Not a never-ending loop, but creating a lot of loops to put the stress on that is basically what it's doing. So this function start stress actually, when I click the button, it's going to actually start that and log it and everything. And then stop stress stops the stress worker from working. So then I have this pressure observer. So I just these two let variables here. And I have just this observer that allows me to watch that pressure observer to see whether it's nominal or what the return of my pressure that I'm putting on it through the web worker, what it's returning. And then I have this start observing function that actually creates the observer and starts it, creates it based off of here. So I create the observer, start it, and then here I have a stop observer here. And then here's my initial setup. So I have this init. All this does is runs through and sees, okay, do we have HTTPS so it's secure? Are we in a Chromium-based browser so we can use this API? Right now, I just have CPU set up because I think that's currently, at the time of this recording, the only thing that the pressure API can watch. And then I'm just grabbing the sources and updating that content, and then just wiring up the UI events, clicking the buttons and things. So nothing super fancy there. But the real magic happens up in, let me find it here sorry, looking through the wrong thing. So up here where I'm checking the state. So anytime this gets called, it gets passed the state to it. So down here, I create the observer. It's constantly every second, as you saw in the log, looking for what the current state is and what the current time is to put it out there. And then when I'm stopping it, it's clearing it all out. So if I go back here, I'm just going to refresh and start observing. Here's the state. And it's just adding to that. It's just doing the observer. I'll just go ahead and stop. So I'm assuming that this will probably get more robust as it gets closer to release, to where you can do more than CPU, and maybe you can also look at memory and things like that. But this again is experimental, so I just put this together really quickly just to have you be able to play with it and take a look at it and see if it can be useful once it's in a released format and no longer experimental. If you have any questions, let me know, and if not, happy stepping.